Hello students, welcome all of you at AriserTalent. How all are you? I hope you are doing absolutely well. So we are on the first chapter of our chemistry class 10th, that is chemical reactions and equations. In our previous lecture, we have discussed about the two methods of balancing the redox reaction. Our first method is oxidation number method and the second number is ion electron method. So we have seen a few steps regarding the oxidation number method, that what steps should we follow to balance the redox reaction by oxidation number method. Now in today's lecture, we will understand both the methods with the help of an example. So it must be clear to you how these steps should be applied on a particular set of the equation. So our first method of balancing the redox reaction is oxidation number method. So our today's topic is balancing of redox reactions. In balancing of redox reaction, we will apply our first method, that is oxidation number method. In our previous lecture, we have discussed about the steps to be followed to apply for the oxidation number method. Now, we will take a simple example to understand the oxidation number method. So, we have our first example in this category. Stannous oxide plus carbon gives Sn plus CO2. So, this is the equation, that is redox reaction we have to balance. Now, we will apply the steps and balance the equation in a simple way. Now, our step number 1 will be write the skeletal equation. So firstly, in our first step, what we are going to do, we have been written a skeletal equation. So the skeletal equation will be the equation provided in the question. So this will be the skeletal equation. This is our skeletal equation. This is our first step. Now we are on our step number 2. Our step number 2 will be write the oxidation state of individual elements in this reaction. So what we will do, write the oxidation state of each element. Now I will write the oxidation state of each element in the reaction. So our reaction is SnO2 plus C gives Sn plus CO2. Now in our previous lecture, we have discussed to calculate the oxidation state of a particular element. I hope you guys will have a quick idea of this to calculate the oxidation state of a particular element. So what we are going to do here is oxidation state of oxygen is -2 and the oxidation state of stannous will be 4. For carbon, it is an individual element, so the oxidation state will be +1. For stannous, the oxidation state will be 0. For CO2, for oxygen -2 and carbon will have an oxidation state of +4. If I am considering the carbon in the individual state, we can also write in the neutral form or in the molecular form, the oxidation state of carbon will also be 0. So this will be the correct oxidation state of the element. So I have written the oxidation state of each element in the following equation. So this is our particular equation, but if I am going to balance the oxygen atom, stannous oxide react with carbon to give carbon monoxide, not the carbon dioxide. So here the product will be carbon monoxide. So in case of carbon monoxide, the products will going to be changed. Here oxidation state of oxygen will be -2 and the carbon will be present in +2 oxidation state. Now this is our step number 2 to calculate the oxidation number of the particular element. Now we are proceeding to our step number 3. So our step number 3 will be calculate the total amount of increase and decrease in the oxidation number. Now we will follow our step number 3. In our step number 3, what we are going to do is we will calculate the increase and decrease in the oxidation number. So in this step, we will calculate increment or decrement of the oxidation number. For this, I am writing this equation again here. So we have SnO2 plus carbon gives stannous plus carbon monoxide. Now what will be the oxidation state here? +4, -2, 0, 0, and for carbon it will have a +2 and -2. Now what we are going to observe in this equation, in case of the stannous, the oxidation number is decreasing. See here oxidation number is +4 and here we are getting 0. And in case of the carbon, it will have a 0 oxidation number and there will be an increment of +2. So I must say that for the carbon there is an increment in the oxidation number and for the stannous there will be the decrement in the oxidation number. So what happens here? In case of stannous, there will be decrease in oxidation number. And what I can say about the carbon, in case of carbon, there will be increase in oxidation number. So there will be the decrement of oxidation number and there will be the increment of oxidation number. If I am saying the oxidation number is increased, the process is particularly called oxidation reaction. And if there is a reduction in the oxidation number, we can say there will be the decrement in the oxidation number, and these are the reaction called reduction reaction. So simultaneously they both are called redox reaction. Now we will follow our step number 4. What actually happens in step number 4? We can see here there will be the decrement of 4 and there will be the increment of 2. So I can say here decrement is of 2 and their decrement is of 4 and there is an increment of 2. So what we are going to do, we will balance the decrement and increment and multiply that factor on the reactant side of the equation. So what we are going to do in our next step, balance reactant side. Now what we are getting here, we have SnO2 plus C gives Sn plus CO. So there will be the increment of 2. So I am multiplying 2 over here. So we are getting 2C in this equation. See here. So this is the equation we get after this. Now we will balance the other side of the reaction, that is the remaining equation, by hit and trial method. So our step number 5 will be, balance remaining atoms by hit and trial. So we will apply hit and trial method and balance the remaining part of the equation. So what will we get in the other part of the equation? We will have a reaction SnO2 plus 2C gives Sn plus CO. So you can see here the carbon atoms are 2 here and oxygen atoms are 2 here. So balancing oxygen and carbon 2 2, I am applying 2 in this subscript. So we will get this equation. SnO2 plus 2C gives Sn plus 2CO. Now you can see stannous is balanced, oxygen is balanced and carbon is balanced, and there is no hydrogen in this reaction, so there will be no need to done the reactions in the acidic as well as the basic medium. So this is the complete balanced redox reaction in this equation. So we can do all the balancing of the equation in the similar way by following the certain steps. So this will be called the complete balanced equation. So I hope this balancing will be clear to you by the method of oxidation number method. If you want to copy it, please copy it from here. So now what we will do, we will take another example in this series and try to balance the another equation. So we will follow the similar steps in the question, only we are changing the example. So our next example is we are taking the another redox reaction, that is CuNO3 negatives give Cu plus 2 and NO2. Now we will follow the similar steps. So I am writing the only equation over here because we are following the same steps. Now our first step is write the skeletal equation that is provided in the question. So I am writing the skeletal equation here. The skeletal equation is Cu plus NO3 negative gives Cu plus 2 plus NO2. So this will be the skeletal equation. Now what is our step number 2? We have to calculate the oxidation state of E is the element provided here. So in this step we will calculate the oxidation state of a number. So I am writing the equation again here. Cu NO3 negative gives Cu plus 2 NO2. Now the oxidation state of copper in this equation will be 0. For copper plus 2 it is plus 2. If I am considering NO3 negative, it means 3 multiplied by minus 2 will be equal to minus 1 because the overall charge on the nitrate ion is minus 1. So how will we calculate the oxidation state of nitrate? It will be calculated as NX plus 3 multiplied by minus 2 equal to minus 1. X minus 6 equal to minus 1. X is equal to 6 minus 1, that is equal to 5. This will be the oxidation state in case of the nitrate ion. So the oxidation state of nitrate in this case will be plus 5 and for oxygen it will be minus 2. Now proceeding to the NO2 ion, for oxygen we have minus 2. Again we have to calculate for the NO2 ion. What we will do in this case, for NO2 ion, X plus 2 into minus 2 equal to 0. It means X equal to 4. So 4 will be the oxidation state of the nitrogen ion in case of NO2. So in this way we will calculate the oxidation state of each element. So we have written the oxidation state of each element in this equation. Now we have completed our step number 1 and step number 2. I hope these two steps will be clear to you. Now we are moving to our step number 3. Our step number 3 will be, we have to calculate the increment and decrement in the oxidation number. So what I am doing here, I am writing the equation again. Oxidation state is 0 plus 5 minus 2 plus 2 plus 4 and minus 2. So what is happening in this equation? See here, copper is having an oxidation state of 0 and after reaction it will be increased to plus 2. So I can write here, there will be the increment of plus 2. Increment, an increment will be of plus 2. Now observe, in case of the nitrate ion, the oxidation state is plus 5 and here it is plus 4. So I must say that there will be the reduction of only one ion here. So we can say that there is a reduction. In case of nitrate ion, there is a reduction, or we can say that there is a decrement of 1. So in this case, there will be decrement of 1. So in this case, there is an increment. So this is the oxidation reaction, and in this case, there will be the decrement of 1 ion. So we can say that these type of reactions are reduction reaction. Now we will balance the reactant side. So I am writing the equation again. Cu plus NO3 gives Cu plus 2 plus NO2. So we have to balance the reactant side. There is an increment of 2 and there is a decrement of 1. So I must multiply the increment number with the other element. So we will balance the equation by doing two over here. Now copper is 2. So I have again balanced 2 here. Now you can see here, copper are completely balanced. Now we will balance the remaining elements by hit and trial method. So N is 1, N is again here is 1. But for balancing oxidation, oxygen and hydrogen atoms, what we have to do, we have to take the acidic or basic medium and add H2O molecules and OH and H positive elements according to the reaction. So I am writing this equation again here. Now we can see here the nitrate is having an increment of 2. So we will multiply the 2 with the nitrate ions, not with the copper ions, because copper ions are already 1 and 1. So what we are going to do, we will multiply 2 here and 2 here for balancing the equation. Now what happens in this case, the reaction we are getting here is Cu plus 2 NO3 gives copper plus 2 plus 2 NO2. So this is the reaction we are getting here. Now copper ions are balanced, nitrogen ions are balanced, but what we can see here, we have 4 oxygen atoms and 6 oxygen atoms in the reactant side. So the reaction is carried out in the acidic medium, so we must add 2 H2O on the product side. So I am writing the further part of the equation here, but before that you can copy it from here. So please copy it now. Now we are on our step number 6. So what we do in our case of step number 6, we will balance oxygen atoms by adding H2O, and by adding H2O we are proceeding the reaction in acidic medium. Now what will happen in this case? We have copper 2NO3 negative, copper plus 2, 2NO2. So we can see here there are 6 oxygen atoms and there are 4 oxygen atoms. So making 4 as a 6, we have to add 2 water molecules here. So we can say that now oxygen 6 and oxygen 2 into 2 4, 4 plus 2 6. So we can say that oxygens are balanced now. Now what we have to do? We have to do the balancing of hydrogen atoms. So step number 7 will be balance hydrogen atoms. So for balancing the hydrogen atoms, what we are doing here, copper plus 2NO3 gives copper plus 2NO2 plus 2H2O. So we are provided with 2 into 2 4 hydrogen molecules. So what I am doing here, I have to add 4H positive here to balance the equation. Now we can say the equation is completely balanced. Copper, nitrogen, oxygen and hydrogen all are balanced in this equation. So I can say that this is a complete balanced redox reaction. So 4H must be added here to balance the water molecule. So this will be the balancing of oxidation number method of redox reaction. We have to follow these basic steps and calculate the oxidation number. This topic is also important from your class 11 point of view, because this will be the balancing and this is very essential to balance the chemical equation. Now we are on our next topic, that is balancing of redox reaction by the ion electron method. I hope this topic has been cleared to you. So we are proceeding to our next topic, that is ion electron method. Hello students, good morning to all of you. We are at AriserTalent and I am your chemistry teacher. So we are on the first chapter of our class 10th chemistry, that is chemical reactions and equation. In our previous lecture, we have dealt with many type of the reaction, calculating the oxidation number of a compound. Now we are on our next topic, how will we done the balancing of the chemical reaction. So our next topic is balancing of redox reactions. So in balancing the redox reaction, basically we are provided with two methods. The first method will be the oxidation number method and the second method will be the ion electron method. So we have the two topics in this. First method is oxidation number method and second method is ion exchange method. So now we will learn about the balancing of the chemical equation in the following ways. First is oxidation number method and second is ion exchange method. So firstly we will learn about the first method, that will be the oxidation number method. So our first topic is oxidation number method. But before discussing oxidation number method, we have to remember some rules for balancing the equation. So some basic rules for balancing the equation in case of oxidation number method will be, first is writing the skeletal equation in a simple form. Second is writing oxidation number of each component present in the equation. Third point is balancing the atoms or ions present in the equation except hydrogen and oxygen. Then we will calculate the change in oxidation. That means there will be the increment of oxygen number or there will be the decrement of oxidation number. So we have few steps here. So our first method, oxidation number method, we have the few steps for calculating the oxidation number, and these steps are: our step number 1 is writing the skeletal equation. Our step number 2 is writing. So our first topic is writing the step number 1, that is writing the skeletal equation of any equation we are provided. Our second step will be, that is step number 2, write the oxidation number of the individual element. So our step number 2 will be write oxidation number of individual elements. Our step number 3 will be calculate the increase or decrease in the oxidation number of element per atom. Calculate increase and decrease in oxidation number. Now we have already discussed our 3 steps. We have our 4th step, that is step number 4. In our step number 4, what we will do here, we will balance the oxidation. There will be the decrement and increment in the oxidation number. We will balance the oxidation number by multiplying that oxidation number on the reactant side. So balance the oxidation number by multiplying in reactant side. This will be our step number 4. Our step number 5 will be in our step number 5, what we will do, we will balance the all atoms present in the reaction by hit and trial method. So balance all atoms but except hydrogen and oxygen, except hydrogen and oxygen by hit and trial method. This will be our step number 5. We will balance the atoms in the reaction. Now our step number 6 will be in our step number 6, we are going to balance our hydrogen and oxygen atoms. So if the reaction take place in the acidic medium, we will add H plus ions in the product side or by adding H2O to balance the equation. But if the reaction occur in the basic mediums, firstly we will equate the negative ions, that is OH minus ions, by adding OH minus ions and H2O in the reaction. So our step number 6 will be balance oxygen and hydrogen atoms. So balancing of oxygen and hydrogen atoms can be done in 2 ways. First, in acidic medium. In acidic medium, what we will do? Firstly, we will equate H plus ions by adding water, that is H2O atoms. Now, if the reaction is proceeding in basic medium, what we will do? We will equate negative ions. We will equate OH minus ions by adding OH and H2O. So, here are the few steps for the oxidation number method. That firstly we will write the skeletal equation. Second, we will write the oxidation number of individual elements. Thirdly, we will calculate the increment and decrement in the oxidation number. Now, balance the oxidation number by multiplying it by oxidizing or reducing agent only in the reactant side. Now, we have all other atoms. We will balance these atoms by hit and trial method. Now, we are left only with hydrogen and oxygen atoms. So, oxygen and hydrogen atoms are balanced. If the reaction in acidic medium, firstly we will equate H plus ions. If the reaction is taking place in the basic medium, we are going to equate OH minus ions. So, these are the basic rule for the oxidation number method of balancing the redox reaction. We will deal with its example in our next lecture. So, this lecture is over for today. Thank you so much and have a nice day.